Okay, so what we're looking at here is exponential functions, and before we get into looking at these graphs, what makes a function an exponential function? Anybody know? It has to the power of something, right? But the exponent has to be the variable, right? So to the power of x, or to the power of some number of x, or x plus something. If you just had y equals x squared, that has an exponent in it, right? But it's not an exponential function, because the exponent in y equals x squared is 2. This one, y equals 2 to the power of x, is an exponential function because the exponent is the variable. So when we look at this one, y equals 2 to the power of x, if we are just doing a table of values using the equation, the first one, 2 to the power of negative 3, that would be equal to 1 over 8. Right? 2 to the power of negative 3, so that changes into 1 over 2 to the power of 3 because of the negative exponent. And then 2 to the power of 3 is 8, so that's 1 over 8. 2 to the power of negative 2 would be 1 over 4. 2 to the power of negative 1 is 1 over 2. What's 2 to the power of 0? 1. Anything to the power of 0 is 1, right? And then 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So we get these y values: 1/8, 1/4, 1/2, 1, 2, 4, and 8. And we end up with a graph when we plot those that looks like this. So looking at some of the characteristics, what's the domain of this function? If you want to put it in set notation, it's x such that x is an element of the set of real numbers. X could be anything. That's going to keep going to the left forever. It's going to keep going to the right forever. What would the range be? Is it YER? No, it doesn't keep going up and down forever, right? It does keep going up forever, but it doesn't keep going down forever. It only goes down as far as 0, or actually not quite 0, right? It's going to approach that, so it's going to be y is greater than 0, not greater than or equal to, but just greater than 0. X-intercept, where does it cross the x-axis? Doesn't. So x-intercept, none. Y-intercept, right there, at 1. And the asymptote, does it have a horizontal or a vertical asymptote, or both? Horizontal. So at y equals 0, right? So moving to the next one, kind of try to keep in mind or keep those close so we can remember, did the domain and range change when we change the base of the exponent? Does the x-intercept, the y-intercept, or the asymptote change? So here's the next one. This is y equals 3 to the power of x. So it's also just a base exponential function where the base of the exponent is 3 instead of 2. So now we do 3 to the power of negative 3, which is 1 over 27. 3 to the power of negative 2 is 1 over 9. And then we have 1 over 3, 1, 3, 9, and 27. When we look at that graph, it looks very similar to y equals 2 to the power of x. It just increases more quickly, right? If you want to see kind of how different they are, graph them both at once on your graphing calculator, and you can see how do they compare, but they're very similar. Y equals 2 to the x just doesn't increase quite as steeply. but it's the same basic shape. So is the domain the same? Yes. What about the range? Same as the first one? What did we say, greater than 0? That looks right. X-intercept, still none. It looks like there could be an x-intercept over here to the far left, but there's not. This line is just going to keep getting closer and closer to 0. And if you think about it, this is as we go into the negative x values. It's just going to be 1 over a bigger and bigger and bigger number. So it's never going to reach 0. It's just going to get infinitely close to 0. Y-intercept, same. Y equals 1, and the asymptote is still at y equals 0. So all of those characteristics are the same for both of those exponential functions. The difference is how steeply it rises. These two, move that out of there. This is y equals 1/2 to the power of x. If you think just about those characteristics, domain and range, x and y intercepts, asymptotes, they're all still the same, right? All real numbers for the domain, greater than 0 for the range, has a y-intercept at 1, no x-intercept, and a horizontal asymptote at 0. And then if we look at this other one, which is y equals 1/3 to the power of x, same thing. The graph looks different to start with, but all of those characteristics that we're looking at are the same for all of these exponential functions. And they will be the same for all of the base exponential functions, so ones that we haven't transformed. If it's just a number to the power of x, you can expect that all of those things will be the same. So this says write the function that corresponds to the graph in the form y equals b to the power of x. So here we're trying to figure out what base number gives us this particular graph with points at 2 and 16, 3 and 64, -2 and something. How are we going to figure out what b is? Yeah, just use x and y, right? So we could use this x and y or this x and y and just fill them in. So 16 equals b to the power of 2. Take the square root. B is equal to 4. Or if we use the other point, the 64 and 3, we'd say 64 equals b to the power of 3, and then take the cube root, we still get b is equal to 4. So y equals 4 to the power of x would be this function.